Welcome to Peterbilt's latest body integration training. My name is Tony Sabler. I'm Peterbilt's vocational marketing manager, and I'm glad that you have joined us. This particular training module is part of a series. It will highlight the benefits that a common Peterbilt electrical architecture provides, including chassis module and solenoid banks that control the air system functionality. Once you're done, I invite you to view the rest of the 2021 Body Integration Series. The first major benefit relates to the consistency of body integration across Peterbilt's trucks. For those of you that are familiar with the prior VECU system on the 567, this will be very familiar. All of our models will be using the same VMUX electrical architecture and air system components. Having all trucks on the VMUX architecture also consolidates the service tools that are needed for new trucks. There are a couple of primary changes in comparison to the prior VMUX system that I want to point out. The first relates to the integration of the air and electrical systems, resulting in a multiplexed EOA or electric over air system. This replaces prior designs that use direct wiring and air supply lines inside the cab. The multiplex EOA system also incorporates a chassis module, which replaces the prior chassis node. With that quick intro, let's get started. There are several components that are involved to actuate the air solenoids for an EOA function. You can see these on the right. And since it is multiplexed, all of them utilize the CAN bus for activation. One of the main points that I want you to take away from this particular training module on the VMUX system is be familiar with the space claim for these components, primarily the chassis module and solenoid banks, since they are mounted on the chassis and can move depending on content. And use the vehicle layout option on your truck spec to ensure that these do not interfere with body mounting. Now, let's get a quick understanding of how an air function is activated. We'll start with pressing the switch in the top right. A signal is sent to the master switch module through the LIN wires that are discussed in the switches module of this training series. The master switch module translates the LIN messages to a CAN message, then sends it to the VECU. Again, VECU is the brains of the electrical system. In this case, it recognizes the air system request, checks any programmed interlock conditions, then sends the signal to the chassis module. Now you'll see two chassis modules here, one standard primary and one optional secondary. I'll discuss the difference in more detail shortly. When the chassis module receives a signal, it recognizes the request and sends the signal to actuate the solenoid. This is where the electrical signal turns into a mechanical or pneumatic action. I hope this explanation helps you understand the basic operation. Focusing on the chassis module for a moment, there are two basic versions. Primary chassis module is standard on trucks and contains the programming and functionality for most applications. The secondary chassis module is driven by specific option content, so the factory will only add it when it's needed. This is not a selectable option in the sales tool. Since many medium-duty trucks are considered to have less complex specs, the medium duty does have a light or LITE version that can be used when option content permits. For the most part, these are fairly invisible to most people. However, there are a couple reasons that technicians may interface with it, including some advanced MX PTO control features or VCAN connections outside the cab. For more information, review Peterbilt's latest VMUX programming guide. Don't worry about memorizing all the information on this slide. It's covered in the bodybuilder manual. The left side highlights the functionality that is contained within the primary chassis module. Note, the LITE version that I mentioned for the medium duty can be used as the primary as long as the functions with an asterisk are not on the spec. If they are on a medium duty spec, then the truck will get the larger chassis module that's typically on Class 8 trucks. On the right side, you see the functions that will drive the need for a secondary chassis module. If any of these options are on the spec, the chassis will have a primary and a secondary. Earlier, I mentioned the importance of knowing where the chassis module and solenoids are located so they don't interfere with body install. This slide shows the main locations for the primary and secondary chassis modules. In most cases, these are routed around the back cab crossmember. However, option content and vehicle layout will drive the need for a secondary and can drive these to other locations. Again, get a vehicle layout to verify. Following the chassis modules, the next step is the air solenoids. They receive the electrical signal and actuate to provide air to the component. For example, the suspension or a fifth wheel slide. Class 8 uses the largest solenoid banks, which contain 6 solenoids. There is a 12 solenoid max on all trucks, except for the 520, where there's a 6 solenoid max. Similar to the chassis module, the medium duty also has a light version of the solenoid, which includes 3 solenoids for lower content specs. And just so you get the point, be familiar with the chassis space claim for these parts. And here you see the common locations for the solenoid banks for each model. Again, they are typically close to the chassis module and back of cab crossmember, but they can move. A good example is on the 520 in the lower right corner. The location of the secondary bank is sometimes a congested area on automated side loaders. The simple point that I want to make with this slide is that additional solenoids can be added to fill a bank. The day-before service tool is required to program the chassis module so the solenoids will work properly, similar to the switches. If you need to do this, I recommend taking the Davy training for instructions on how to program the switches and solenoids properly. Here are a couple examples of some aftermarket upfits that may require this. There are a couple benefits that come with a multiplexed EOA system. It allows programmable interlocks for protection. The chassis module has additional capacity beyond the prior chassis node system for additional growth, and it is capable of detecting and storing fault information for improved diagnostics capability via the Davy tool. Before we close, a couple points that I want to reemphasize. First, be sure to use the vehicle layout to verify frame space for body integration. And second, Davy and PVP service tools are needed to program additional switches and solenoids that are added. To become more familiar with these tools, attend the available service trainings. Peterbilt has many online resources that you can access. At peterbilt.com, select Bodybuilder Resources from the drop-down menu for the latest bodybuilder manuals, operators manuals, and product literature. It also has a link to Peterbilt's YouTube channel. Go to the Bodybuilder Resources channel to view more videos. More importantly, subscribe to the Bodybuilder Resources channel so you receive updates when new videos are posted. Next, PeterbiltOneSource.com for literature, product guides, and videos. And PACCAR.net, which replaces ePortal and DealerNet. This is a great place for technical information. And PACCARPowertrain.com for information about PACCAR's engines, axles, and transmissions. This module has just scratched the surface of information that you want and need to know. For more information, be sure to watch these additional Peterbilt body integration modules, which dive deeper into each of these important topics. I hope you have enjoyed this module on 2021 VMUX chassis air systems, and I look forward to our next opportunity to work together. Thank you.